So hello everyone. So as we can see that we have a Python program that encodes a flag using base64 encoding, reversing and XOR operations with the help of a dynamic key. So this layered approach makes the encryption process a bit more secure. So let's have a look at that code. So we can see that we have a flag value. So firstly we have a hint. So so this from this flag value, this part of the flag will present in our flag value exactly before encoding. So this will be like as it is. So the second clue is that the assert key length equals to 8. So this key length 8 means after encoding the length of our key will be 8. So first let's have a look at how this base64 encoding works. So let's see a picture. So here there's a base64 character. So if first it's converted to decimal value, then its respective binary value 6 digit, then this 6 digit binary value is extended and converted into 8 digit binary value. Then this 8 digit binary value is converted to ASCII value, and then it's to its character value. So we have 8 length, which means if we convert it, then we'll get 8 into 6, that's 48. So if it's 48, then we have a we will have a length of 48 divided by 8, then we'll get 6. So before encryption the length of our key will be 6, and after encryption it will be 8. So that's the two clue we have found. So let's dissect the code. So start from import base64. So it's a library. It enables us to encode and decode data in base64 format. So this type of encoding is often used for converting binary data into text that is easy to handle text-based systems. So then we have flag and the key. We can see that. So flag contains the data we want to encode basically, and as we have said, this part of the flag will be already present in our original flag as it is. Then it representing a secret flag, which means this part will not be. So this part we have to find out later by decryption code, that what this part of the flag can be. And as we can see, there is also key which is not the exact key also. So key is the secret key used in XOR operation to encrypt the flag. So both of these are placeholders where actual values should be substituted during execution. So let's move forward. So we have these two function. So firstly we'll go for the flag encode function. So flag.encode function basically converts a string into bytes, which is necessary for base64 encoding. And here the base64.beef64 encode, this function encodes the bytes into base64 format. Then the decode function is basically converts the base64 bytes back into a readable string. So then here comes the uh, which is basically doing the same thing for flag and the key. So it's just encoding process. So here we are storing the flags, what we have got in the flag in the reverse manner. As we know in Python, this means to reverse the string we have, and it's storing in a variable which is also called flag. Just it's just overwriting the flag variable. And we have a encrypted enc flag, which means we are taking as empty string, naming enc flag. So then we are going to the key length, which will be the length of the key, and the flag length, which will be the length of the flag basically. Then assert key length 8, which is just ensuring the key is exactly 8 characters long after the encoding process. And the assert flag length modulus key length equals to 0, which is just ensuring that the flag length is a multiple of key length. This simplifies dividing flag into a bunch for encryption process. Then we are initializing a k index, which initializing from 0. Then we will dive into the loop. So let's move forward. So we are ensuring in the loop that the it the loop goes until the uh, uh, first half of the just half part of the flag length, so which means the flag uh, each flag length floor value of 2. So which means that we will just we use the pairs of character to process this symmetrically. So here ord of flag of I, which means we will just get the ASCII value of the current character from the front part of the flag. Then this sign, which is just means the XOR sign, and then we will get the this process, uh, which is just also getting the ASCII value of the current character from the front of the flag. uh, sorry sorry, gets the it will just get us the uh, ASCII values basically of the corresponding character from the end. It just getting us the from the ASCII values from the end part of the, not the front. The above this part is going working for the front part, and this is just could getting us the ASCII value for the back part of the flag. Back. So then this is the XOR sign, and this is just getting us the ASCII values of the respective key characters. So then we will just move into the if condition. So if k index equals to key length minus 1, so if our index that we have initialized initially, so if it is reaches the key length minus 1, which is the last character of the key, if it reaches the last character of the key, then we will reset the value of k index to 0. So we will reset it, and then we will reverse the key value. So if we reaches at the end of the end character of the key value, then we will just reverse our key and initialize the k index to 0. And if it doesn't happen, so until that happen, we will just increment k index until we reaches into the last character of the basically key length. So then we will print our encrypted flag. That encrypted flag means with this array's value, so we have stored our encrypted values in this array. So basically this array will store all the encrypted value we have got from our flag. So this flag and key, so basically this is our encryption process. So now we have to decrypt the uh, code. So let's move forward to the decryption part of our code. So basically here it also starts with our uh, it is also starting with our import base64. So as we have mentioned it earlier, so this is this is a library which is allowing us to encode and decode data in base64 format. This encoding is it's commonly used in transforming binary into text. Then we have the flag equals to this function, which is just to encode and as we mentioned earlier, this part of the flag that we have seen in the encoding code will remain as it is in our actual flag. So we have kept it here. Then we have just flag equals to this, which means this will just encode the flag. This part of the flag, it will be encoded and stored in the flag. That bracket, second bracket open, this will be encoded and will be stored in the flag variable, and we have printed the flag variable. Then we have initialized functions which is find by XOR, and we have passed the argument num and target. So in the result we can see that the target has been ASCII valued, and we have got an ASCII value to our target, and we have XORed it with our the number we have passed. So after we XOR operation, so it's a fundamental cryptographic technique to that flips the bits of the ASCII value. So if we see the how XOR bit by bit operation occurs, so we can see here that if the uh, if we both XOR operator has the same value, then it will give output as 0, otherwise it will give as 1. So we can just match the if the bit by bit, we can match the bit by bit wise, that if the both operator has the same bit by bit value or not. So in the return CHR result, we have converted the resulting number back into the character. So this function will be used repeatedly as we have to encode and decode characters in the flag and key. So in the find key function, we have passed argument flag, and we have uh, at first we have taken the output array, which is our encoded value of the encoded array. So this will have a list of numbers that represent encoded data. So this will help to derive the key. So we have initialized a empty string as key variable also. Then we have initialized the loop. So we can see the loop here. We can see the loop. So in the loop, so for for index in range of length of flag, key, the empty string will be filled up with a string. So we have just added it. So what is it? So find XOR function. So we have just XOR use the XOR function and find by XOR, and the output array of the index into 2 plus 1. So which means we are accessing the every second element in the uh, our output array, and these numbers are XORed with each character in the encoded flag, and to extract the key one character at a time. So Then we have returned the reverse of the reverse of the key of one character at a time that we are getting from that string. So, sorry, from that function. So why did we reverse it? Because in the encoding part, uh, if we can remember that we had reversed it, the encoded value, so that encoded key, so that uh, the encryption becomes stronger, that it can be deciphered very easily. For that reason we reversed it. So while we, so to get the exact key we have to reverse it again. Now in the key we will use the find key of flag. So we'll just do the same process for flag our flag, and the array is present here again. So this we have used the array, and now we will use the find flag function. So we have found the key, and now we need the flag part. So the flag part we need, so here is the key basically. So and we need to find the flag. So for that we have to understand the code. So for the find flag we have to uh, basically the flag, it is a empty array. So where the data type will be string, and the length of the uh, flag, the array length of the flag will be the output of output array. So the number of elements in the output array, the flag will have the same amount of elements in its array. So flag length will be also the length of the output array, which means the number of elements there. And k index, as we have seen before, we have initialized a value which is 0, which is k index. Now key length will be length of key, we also always know that. So now we have used the loop where length of output of array divided by 2, floor value of 2 has been used. So uh, key in, it's just loop process pairs, loop process is processing the pair of numbers in the encoded output. The first number in the pair is decrypted forward wise, and the second number is decrypted in backward wise. So basically the it's just from the first, one from the last, this way. So one number, first number is in the pair is decrypt what we are taking pair by pair, and first number is decrypted forward wise. So we will just decrypting it in forward process, and the second number is decrypting, we are decrypting in its backward process. Then if the uh, key index reaches the final position, final character, as we have seen, then we are resetting the uh, key index variable as 0, and then again we have initialized a variable key which will be reversed, and after reversing the key equals to key, uh, we have reversed, and if it doesn't reach the uh, last character, then we are incrementing the value of key index. So it will just go on until it reaches the last character of the key. So then we are returning the flag in a reverse manner, as we have seen that we did also uh, encrypted the flag after we are reversing it. So to just to make it stronger encryption, so we have to reverse it back again to get the original flag. Then we are bringing it together. Then we are we have to decode the flag, we are just uh, keeping the variable, and we have just find flag. We are using find flag, that function we have used to find the original flag, and giving the argument key and output array, so that to here the flag will be stored. But however, we have seen in the find flag the output is uh, coming in an array. Here flag is an array, so the our flag is in a array, but we have to show it as a string. So to do that, we have used an empty string dot join flag, which means the element of the array will be joined as a string, and it will be a string now. uh, this flag variable will now store a string. Now this flag variable is just base64.b64 decode, so it's just finally decoding the flag value and printing the flag value. So this is basically our flag value. So this is basically the flag value we were searching for. Thank you so much, guys.